Yes. Hello there, I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900 to 95 from Zurich International Airport, runway 1 Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 1449, let's localize our landing zone. I'm in the cockpit for the pre-takeoff preparation with the quality wings. Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments and displays and the functions of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display. That displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, and the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands of feet per minute, or the steepness of trigonometric angles in decrease and get climb and descent. We have also the artificial horizon with the altitude indicator, the big slider decrease, and the bank angle in decrease. We have the Lszh localizer of the instrument landing system. We use of the runways of the airports, runways we use for takeoff and for landing. So we have the threshold antennas of each runway that transmit the radio frequency. There has a unique radio receiver frequency, so we can tune and receive the radio signal. We can align with the horizontal localizer and the vertical glide slope of the Lszh system. The instrument landing system is the horizontal localizer and vertical glide slope for the angle of approach. So we have also the onboard antennas that receive the Lszh localizer, and we have also to align with the magnetic north pole heading. So we have the Zurich International Airport runway 14. We're going to be aligned with the runway 14 magnetic north pole heading and Lszh frequency. We have also the Lszh localizer crossbus. We have the flight director crossbus for manual guidance of the aircraft, and the autopilot crossbus for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, and the fly mode on 0 with the autopilot and the auto throttle. Later on vertical navigation mode. We have also the HSI, the horizontal situation indicator that displays the magnetic heading and track, and also the integrated display of the flight plan. So we have the flight plan displayed. We're gonna use the flight plan on the computer, and we're gonna create a flight plan. Use it displayed both in the navigation display and the integrated display of the HSI. So in the navigation display, we have the horizontal and vertical profile of the aircraft as it flies. We have the terrain and weather reflections from the weather radar. You can see the terrain displayed with red, green, and yellow or amber indication. Also, that displays the elevation and the distance, depending on the distance the aircraft is, and also the elevation of the terrain above or below us. So it changes colors. We can see also the lakes and the rivers with blue. So we have also the terrain map displays the airports. We can see where the airports are located. Our own airport, the Lszh in Switzerland, can see the 4-letter account name of its airport, and also we can see the runways we're gonna use for takeoff and for landing, and the taxiways from the GPS system. You can see also the runway length and the direction, the heading of the runway. So we have also the GPS coordinates, the latitude and the longitude. We can align using the inertial reference system and the flight management computer to make an inertial alignment. We have also the magnetic north pole and the geographic north pole, and magnetic variation depending on where we are in the world. We have the display of the horizontal and the vertical profile of the aircraft as it flies. Also we can see in the navigation display, when we're going to create the flight plan, you will see it displayed with a purple Roman Zeta line, and one waypoint by another is going to be connected as the legs of the flight plan. So we have also in the navigation display, we have the display of other aircraft that fly around our own aircraft using the transporter. There is the ADC transmitter receiver that transmits our frequency to other aircraft, and the air traffic controller interface from other aircraft can make calculations from its computer. It can calculate from the radio frequency difference where the other aircraft are located, depending with our aircraft, the distance they are located from our aircraft, and bearing also the altitude difference from our aircraft, how many hundreds or thousands of feet are above or below our aircraft. It can also calculate whether they climb or descend. We can also calculate with respect to our aircraft. We can also calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning from the TCAS system, the traffic collision advisory system. It will be displayed in the navigation display. In the primary flight display, we have to make an avoidance maneuver in the air or in the ground. Also, you can show us the taxi in the runways and the taxiways, the other traffic. So we have also the navigation display. We have the wind direction and speed, also the ground speed of the aircraft component also. So we have other things to see, other instruments inside the cockpit. I'm gonna show you the autopilot flight director system panel, the ACAS, the engine indication and control system display, the thrust levers, the flaps and the slats, the speed brakes, the horizontal tail elevator and trim stabilizer. So we have to trim the horizontal tail when we fly, or the elevator depending on the aircraft model. So we can balance the aircraft in the air. I'll show you how to do it either manually or automatically. So we have this aircraft, the Boeing 787 is fly-by-wire aircraft. As you can see, it has its flight control computers over here that control the flight controls, primary flight control computers in the auto position. We have also the air data computer over here, heading reference, IRS. We have the flight control surfaces in the overhead panels. I will show you also the overhead panel systems later. So you can see here we have the flight controls. We can use, I have my side stick, the Lszh Extreme 3D, which is identical to the Airbus side stick, so I can use this side stick to control the function of the flight controls of the Boeing 787 in the Microsoft Flight Simulator. So you can see I can climb and I can descend like this. I can make turns to the left and turns to the right, also using the control wheel. So we have the pitch axis for climb descent, the roll axis using the control wheel or the side stick left and right, or side stick climb the descent in the Airbus is back and forth, and also the rudder pedals for the vertical tail, which is the yawing axis. Also controls the tiller, the nose wheel steering is interconnected in the ground for controlling the nose wheel of the aircraft. So I will show you also the outside view now of the aircraft. So you can see also we have the thrust levers over here. We can control the thrust commanded by the engines over here. So I have this slider to command the engine's thrust position like this when we fly the aircraft. So you can see the thrust levers position and the engine's commanded position like this. So we have here you can see all the indications of the aircraft. So we have autopilot flight director system panel, the displays. So you can see here we have the flight controls. You can see here the control wheel. I use the side stick to control and climb and descend the side stick. So we use the outside view. You see I'm using the flight controls over here for climb and descent, for instance, the rudder pedals to control the aircraft in flight, bang rolls left and right like this. So we have full flight controls. I will talk to you in a couple of minutes. So we have the displays first over here. Perhaps first the primary flight display. You can see here the airspeed tape, the airspeed indicated. It increases when we go for flying. The airspeed selected from the autopilot flight director system panel. Over here the ground speed is gonna be displayed here in the navigation display, as we see. The barometric altitude above the sea level over here 1430 feet. For this barometric pressure setting 29.92 is displayed inches of mercury or 1013 hectopascal, the radio minimums. So we set the barometric pressure altitude over here from the FS panel. You see this display here, this switch. We can turn around and set the barometric pressure in inches of mercury. We have it in standard 29.92 or hectopascals, HPA 1013. You can set also minimums and barrel, plan, menu, page displayed, and the range, weather, radar, traffic and terrain on the display. The navigation display over here, weather, radar, traffic, terrain, accept, cancel, reject, some warnings over here. So we have also many indications here for the navigation display, the primary flight display. I will have to explain. Also the systems display checklist, system checklist, CDU info, navigation display left and right, engines and ACAS. You can change and expand the display over here. Like in the other side, have an expanded view of the map or have the engines and other systems displayed there. You will see later in a couple of minutes. So we set the barometric pressure here, altitude barometric pressure 39.92, inches of mercury at 1013 hectopascals over here. So you see displayed flight director, also the vertical barometric altitude, target altitude selected from the autopilot flight director system panel, vertical rate of climb descent of the aircraft in tens, hundreds and thousands of feet per minute. So it's like 500, 1000, 1500, 2000, 3000, 6000. You see neither moving up or moving down when we descend, moving up when we climb. So we have the pitch ladder here in degrees, 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 for pitch up or pitch down, the pitch altitude of the aircraft in flight, and the wings level over here, this angles symbol. We have the flight director, also the Lszh, and the primary flight display. You can see also the autopilot display with the same information. Also we have the bankroll of the aircraft when we make turns, like 5, 10, 15, 20, 30 degrees, 45 degrees left and right, like this. You will see how many degrees, this symbol. Also the takeoff ground over here arm. Also in the HSI you can see the ADF left and right for alignment. So we have the heading over here selected 360 degrees, the altitude over here selected 10,000 feet, and the airspeed 200 knots. So it's the same values as you can see in the autopilot flight director system panel over here. You can see 200 knots nautical miles per hour, 360 degrees heading, vertical speed right now is not selected, and 10,000 feet altitude. So you can see both sides over here display the same thing, 200, 10,000 over here of the primary flight display, the captain and the first officer. So you can see 200 knots nautical miles per hour, indicated airspeed or Mach speed, so it's nautical miles per hour. Autopilot engages and disengages over here, and nav and VNAV, flight level change, climb continues, auto throttle, flight director on and off. So we'll set the airspeed later. Also the bankroll, the heading, vertical speed, and the altitude where localizer approaches for autoland. So you see 200, 360 and 10,000 is now displayed in the primary flight display here, 200, 10,000 and 360 degrees, so 0. You can see also in the navigation display here, we have the altitude and the heading also displayed. So the altitude in the vertical profile, you can see the aircraft when it's flying, how far above the ground we will be flying the aircraft. You can see the terrain below you displayed with the green, yellow and red indications. And you can see the altitude selected is 10,000 feet, the same one like the primary flight display, and the autopilot here, we will change that later. So we're gonna have also the flight management computer over here, all the data, set up the flight plan, the thrust levers, horizontal trim stabilizer over here, horizontal trimming. So you can trim the aircraft for flying. We have the pitch trim over here, the control wheel, we have the pitch trim. So we can set the pitch trim, so it's here, you can trim like this. You see elevator over here, elevator trim, left click down, right click over here up. So it's left click down, right click up over here. So you trim this way, you pitch the nose up, and this way you pitch the nose down. You trim the elevator up and you trim the elevator down, so it has the aerodynamic effect like this in flying. So you balance the aircraft in the air. So you can see elevator trim, left click down, right click up over here. Also we have the head-up display over here, the declutter, and also the autopilot disengage over here. So we have also the alternate trim of the horizontal stabilizer. You can see stabilizer alternate pitch trim, nose up and nose down. So it's the same thing again, nose up and nose down like this. as you can see. So this way you trim the elevator up, this way you trim the elevator down. So this switch over here, and you trimming and you balance the aircraft in the flight conditions, and also you can fly hands off. So this way you trim the elevator up, this way you trim the elevator down, this way it pits the nose up, this way it pits the nose down. Same effect, trim elevator up, pits the nose up, trim the elevator down, pits the nose down. So we have also the stabilizer cut-off switch for the auto trim system. We have the parking brakes also over here. We have set the parking brakes. We have over here the stabilizer trim switch that I'm telling you, the manual trimming. Elevator, as you can see, elevator trim, left click down, right click up. So you can see the elevator position. It's not like the trim wheel, actually it's a little bit different. So you see the position here. Right now we have 4.75 degrees nose up, so we'll use a little bit less than that in the display. You can see stabilizer trim here, 4.75 degrees. Inside the green button is for takeoff. Limit rudder trim. Also some indications from the engines. We're gonna see later in a couple of minutes. So we have also we have the flight control computers that I'm telling you. Primary flight control computers over here in the auto position. We have the normal and the alternate and the direct flight control computers. So we have the flight control computers as a fly-by-wire aircraft. We have the channels of the flight control computers, the normal, the alternate, and the direct. Like in the Airbus, we have the limits in the turns, G limits like 2.8 degrees, 2.8 G acceleration of gravity, 2.8 G load in left and right turns is for the Airbus, and 67 degrees. Limit also is like 30 degrees inclined and 1.5 G inclined, and also descent like -0.5 G and -15 degrees descent. So it's quite similar for the Boeing. When you make turns or climb or descent, you give an order for G load limit that reflects the flight control surfaces identically, proportionally to the G loads you want to do. I'm not sure about the limits of the Boeing, but when you move the flight controls like this, you also have an order for the flight control computers, like in the Airbus, in the newer Boeing 787 and Boeing 327. So you can see how many degrees you pitstream the tail over here, the elevator, for flying to balance the aircraft in the flight conditions. So we have a couple more things to see. The flight controls here. So we have I will talk to you now about the Newton's physics, aeronautical and aerospace engineering, and derive some principles we need to know for flying the aircraft for the air transport pilot license, the commercial pilot license. We need to know some aerodynamics. So I'll show you how to use the outside view of the aircraft and derive the aerodynamics principles. You can see also one aircraft is coming for landing now in the runway 16. So I'll show you now over here the outside view of the aircraft. You can see the wings of the aircraft hold the weight of the aircraft as the aircraft flies. The air weight is divided over the surface area of the wings. We have also the jet thrust from the engines, the propulsion that move the aircraft forward. We have the exhaust cones from the engines, the nozzles that send the jet blast off the engines, and the bypass of the engines, the jet engines. We have also the compressor, the high pressure and the low pressure compressor and turbine, and the front fans, the combustion chamber. So this moves, these vectors move the aircraft forward. We have the mean aerodynamic chord position, the Mach, which is 23% of the mean aerodynamic chord, where the maximum aerodynamic lift occurs in the forward wings, where also You can see we have the fuel tank, the center tank over here, and the left wing and the right wing fuel tank. So we have 30% in the left and 30% in the right and 10% in the center fuel tanks. So we have the center of gravity here located. You can see, so the center of gravity goes down this way. Also in the top surface of the wings we have the center of pressure, moves back and forth, and also the airflow becomes detached as we fly for a given angle of attack and airspeed that increase or decrease. So we have the stall of the wings. When we fly, the airflow becomes detached and makes the aircraft falls from the sky. So we need to pay attention to monitor in the primary flight display over here all the time that the airspeed is always above the stall speed. Down here is going to be displayed with an amber and red indication over here. So we need to apply more thrust and push the thrust. Push over here the side stick down, or the control column, the yoke of the Boeing 787, or the side stick of the Airbus, and apply more thrust to avoid the stall of the aircraft in the air. So we have this is a vertical axis with the center of gravity transverses. The mean aerodynamic chord position is also the yawing axis of the aircraft. You can make left and right turns like this. So you can yaw the aircraft left and right, make left and right turns using the rudder pedals over here. The rudder pedals inside the aircraft like this. And also you control the nose with string in the ground in takeoff or in landing. Also having the tiller for that. So the nose will string. You can see we have the forward nose wheel over here. It deflects with the rudder pedals or the tiller 76 degrees left and right. From 0 knots over to 45 knots. We have the rudder then coming in, aerodynamically effective from 45 knots. Nautical miles per hour in takeoff or in landing. So we have the nose wheel. It decreases the forward nose wheel over here to 7.6 degrees up to 70 knots. Then it deactivates, it locks to 0 deflection. So we have only the rudder aerodynamically effective because we don't need the nose wheel above 80 knots or 144 kilometers an hour. So we have the rudder for directional control in takeoff, in landing, in the runway, also in fly. So you can see the yawing axis like this. We can yaw through the center of gravity like this using the rudder pedals only. And the nose wheel string, the tiller for the nose wheel. So we have 76 degrees left and right nose wheel. Then it decreases at 45 knots, 7.6, deactivates above 45 knots. Also we have here this axis from wingtip to wingtip is the lateral axis over here. So the lateral axis in the Airbus is the side stick climb and descent like this. So you climb and you descend like this. In the Airbus is the side stick input back and forth to pull the elevator, and horizontal tail elevator, horizontal stabilizer elevator, call it as you want, to climb and descend the aircraft. So this way you climb, you can see, this way you descend. You can see the whole arm setup over here. Also the mouse pad that I have. So we have to climb and descend like this is the side stick. So you use the control column or yoke of the Boeing 787 in the Boeing aircraft for climb and descent like this. So you climb, you descend, make turns to the right, make turns to the left. You can see the side stick deflection is proportional to the yoke deflection. Also in the air. So we have full deflections like this. for climbing, for descent. Also we have one more axis from the nozzle all the way back to the tail. It's the longitudinal axis. It's the side stick left and right in the Airbus. You make left and right turns like this. It's the control wheel in the Boeing aircraft, so you make left and right turns using the side stick, left and right deflection. You see the roll, you roll using the aerodynamic effect of the aileron, spoilers and flaperons in the Boeing, or just the ailerons and spoilers in the Airbus aircraft. So we have all flight controls axis like this. So you see is the control, the side stick left and right in the Airbus. Up and down is the yoke, all side stick in the Airbus, the yoke in the Boeing. Also the control wheel in the Boeing, left and right turns like this. So you have full directional control. You can trim the horizontal tail over here, use the thrust levers. And I have to show you one more view of the aircraft of the Boeing 787 flight controls. So you'll see now one more view of the flight controls of the Boeing 787. I will explain you again the system, the flight controls function with a better view inside the cockpit. So I'll talk to you about a couple more things about the flight controls of the Boeing 787. You can see here how we have the side stick again. So after that I will talk to you about the aircraft systems. I'm gonna set the flight management computer flight plan and make the engine start demonstration. Stay with me until the end part of the video. You will see also the engine start demonstration and a complete flight from takeoff, climb, cruises and approach and landing. So we see now again the side stick here, the view of the cockpit also. So we have over here one more view of the aircraft Boeing 787 with its flight control system. Also you can see the view of the screen a little bit better. So you can climb, you can descend, you can make turns to the left, turns to the right like this. So you use the pitch axis, the elevator for climb, descent. Also the side stick left and right in the Airbus is the control wheel, as you can see in the Boeing. Also the rudder pedals, the horizontal trim stabilizer, the thrust levers like this, can increase and decrease the thrust commanded to the engines over here. So you have the engines set over here. So you can see the side stick deflection is proportional over here to the yoke deflection, as you can see. Also the captain and the first officer are moving together, they're interconnected in flight. All flight controls move simultaneously together unless you have a failure, you want to override with a force one side by another. You have the side stick priority in the Airbus, which is a little bit different. So here all flight controls are interconnected together. So hope you like my Airbus side stick over here, as you can see. So we have also to see the outside view one more time here of flight controls again. So this is enough for the flight controls, I believe, of the aircraft. So you see again deflection left and right over here, aileron spoilers. Thrust control. So this is all for the flight controls. Right now we will go inside the cockpit again and look up the flight management computer. So go back inside and see the rest of the systems we need to know. So that was enough for the flight controls tonight. I'll talk to you about the rest of the systems of the Boeing 787 right now. I'll show you the flight management computer, how to use the flight management computer, also the engine indications. So we have the engines are displayed from the FAREX. We have the Flught. This is electronic control computers, one installed per engine gearbox, dual channel redundancy. If one channel fails, the other takes over, controls, monitors and display all the engine data using the upper and the lower ACAS, all the multifunction display, like the N1, which is the low speed starter sub low pressure compressor and turbine of the turbofan engine, exhaust gas temperature per engine, N2, which is the high speed starter sub high pressure compressor and turbine of the turbofan engine. Also the fuel flow per inch per hour, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. Also it controls the outflow valves of the 5th and 9th stage, and the bleeder from the engines, from the bypasser. We supply the cabin pressurization, oxygen regulation in the cabin, pressurizing the cabin, and also hydraulic fluid tanks pressurization and wing and engine RDIs. So we have many systems supplied from the engines pressurization. You can see another also aircraft coming for landing right now. Hope you like also this aircraft. Another Boeing 737, I think. Yes, and here it comes. So we have the engine indications here. You can see we have here the N1, which is the low speed starter and sub low pressure compressor and turbine of the turbofan turbine engine, the left and the right. The idle thrust right now 19.7, takeoff thrust 99.2, the green limit. Over here you can see this mark, the red and yellow, never exceed takeoff. Total air temperature, exhaust gas temperature right now 447 degrees Celsius. The N2, which is the high speed starter sub high pressure compressor and turbine of the turbofan turbine engine, the high speed shaft and spool, and the low speed shaft and spool, high speed shaft and spool. So we have the N2, we have the fuel flow per inch per hour, 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engines over here. You can see also the bleeder supplied for cabin pressurization here, the outflow valves also to pressurize the cabin when we climb, descend, open and climb, open or close, climb or descend. We have the cabin altitude right now is the same one like the altitude we are, 1400 feet, rate of climb, descent, differential pressure. So when we climb to like 43,000 feet, maximum climb altitude for this aircraft, the cabin altitude inside the aircraft will be like 6, 7 or 8,000 feet, and the differential pressure should be maximum 7.8 or 8 psi. The landing altitude to select manually displays. So you can see the cabin pressurization panel over here from the other systems. Right now it's in the auto position. The outflow valves also I will show you in a couple of seconds. So we have the engines indication. When we move the thrust levers, we command the engines thrust over here to produce some rating, some limits. So you can see we can move forward. We have more thrust commanded over here right now. We can use the takeoff thrust. It will give us a warning will not configure right now for takeoff. So we have the thrust reverse. We have the auto throttle over here. Disengage switch, disconnect this switch over here. Takeoff, go on. Also, the fuel flow to the left and the right engine. We have the speed brakes over here, which are secondary flight control. Also the flaps position over here. Remove the flaps up or down, extend and retract, extend the surface area of the wings. So we have the fuel control, left and right engine, turn on and off the engines, left and right. Fire extinguisher, left and right engine, pull out and switch the transporter. Rudder trim, radio and communication panel. We can tune the radios here. VHF, high frequency, very high frequency satellite. Ground proximity, weather radar, transporter. Also, so we can use this now, the flight management computer. So I will show you now the flight management computer, how to create a flight plan using the flight management computer. I will link with all the data of the aircraft for this flight. So I will use the takeoff gross weight and includes the empty weight plus passengers plus the cargo plus the fuel on board. Where the fuel is stored in the left and the right wing, how much we have, 30% in the left wing, 30% in the right wing, and 30% in the center tank. The flight management computer is going to calculate the center of gravity from takeoff, climb, cruises, and approach and landing during the whole flight. We burn fuel, so and also change altitude in flight, so the center of gravity is shifted and is recalculated by the flight management computer that also commands the flight control computers and the autopilot flight director system panel, the auto throttle and other systems. So for the takeoff we have the center of gravity, the aerodynamic core position, 23% of the map. That also calculates the horizontal tail trim elevator position. We're gonna have 4.25 degrees of horizontal stabilizer trim position for takeoff. Also we're gonna use 15 degrees of flaps. We're gonna select the runway. We have the Zurich International Airport and we're gonna use the runway 14 both for takeoff and for landing. You can see the runways. The runway 14 over here. We're gonna taxi using this taxiway. So we're gonna have the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air. Also the runway conditions, civil size, dry or wet. It's gonna give us the takeoff speeds, V1, V-rotate and V2. So we're gonna have full takeoff thrust power for takeoff, like 99-100% of the engine's thrust are commanded. So we're gonna be having also for takeoff thrust, we're gonna be having 9 degrees of pitch attitude for takeoff rotation and 15 degrees of flaps. We're gonna climb using the scissors, other instrument departure waypoints and fixes. We're gonna have about 140 nautical miles knots per hour airspeed for takeoff, or about 250 kilometers an hour. So we're gonna be climbing. We're gonna have the scissors, other instrument departure waypoints and fixes that include horizontal and vertical navigation fixes and altitude and airspeed constraints for the initial climb and departure of the aircraft. We're gonna climb to the cruise level at 35, 36, 37, 38, 29, 30,000 feet above the sea level. We're gonna cross through some waypoints over there. Then we're gonna be make some turns. I'm gonna descend back to the airport. Elevation like 7 or 6,000 feet above the sea level. We're gonna be aligned with the SARS, the SAR terminal arrival waypoints and fixes that include long final and short final approach fixes for the terminal approach and landing of the aircraft. We're going to be aligned with the stars and also with the Lszh localizer, the instrument landing system that transmits the radio frequency from the threshold antennas of the runways we use for takeoff and flying. So we have the runway 14 and its own Lszh localizer with its own radio frequency. So we're going to receive from the onboard antennas of the aircraft, and we're going to be aligned for the horizontal localizer alignment with the magnetic runoff ball heading of 136 degrees for the runway 14 in Zurich International Airport, and also with the vertical glide slope for the angle of approach. We're going to be having 35-30 degrees, so flaps also extended, and an airspeed of about 160-170 knots, about 270 kilometers an hour, and also the landing gear extended, and a pitch altitude of 9 degrees and less, and also the thrust commanded to like 60 or 70% of thrust. And we're going to be having the approach and landing full flight, also a less localizer in normal flight. So you will see how I'm going to set up the flight management computer right now. I'm going to use, you can see I'm having this computer here, and also you can see the computer screen, the aircraft inside over here, the cockpit, the keyboard I'm gonna use, and the mouse pad I'm using for controlling, also the side stick. So I have the full setup here, so we can use the flight management computer over here of the aircraft, and having my own mouse pad. We have also the mouse pad of the aircraft here. We can use the touch screen over here, as you can see, to input what we need in the display here. So we have the primary flight display, we have the flight management computer, we have the keyboard of the computer, and the CDU, control display unit. So we can input identity, position, performance, takeoff, approach, annunciate status, and navigation to the flight plans, loaded traffic control, load flight plan. So we can use here, also we can input here in the screen if we need. So I'm gonna use over here control quadrant. So you see again from this view the mouse pad and flight management computer, the engines, and the flaps. Also this view of the cockpit. So we're gonna use identity over here, position. So we have the identity is the Boeing 787-900 with the GNX engines and the air cycle. The position, Lszh airport, we can align the inertial reference system, make an inertial alignment for the longitude and latitude of the aircraft. Performance here, 0 fuel weight plus fuel on board. We have the gross weight for takeoff, the reserves, cruise altitude, cost index, center of gravity in flight, and fuel temperature, freezing. So we have a Lszh. We're gonna use first the orienting, create the flight plan first, the waypoints, route of flight path. So we have a Lszh, copy paste here, clear. Use runway 14 for takeoff, and then departures. Over here we'll select the runways, either runway 10, 14, 16, 28, over here 32. So we're gonna select the runway 10, and the seats that are arranged in the departure waypoints and fixes, we're gonna use Zui to Alpha. So we have the departure set. We're gonna set also the arrival over here. So we have 16, 28, 34, ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we're gonna use ILS here 14, Transamiki over here, and also the stars, the other terminal arrival waypoints and fixes. We're gonna use the Negria 1 Alpha. So we have the legs over here. The route is displayed with blue, and the first waypoint 136 degrees heading, so it's not yet active. Climb to the Zui, make a left turn here, make a right turn here, descend, approach, and landing Zurich 701. So we have the 0 fuel weight here, 302.7 plus fuel on board. We have the gross weight 5% reserve, and 25,300 the cruise altitude. So we're gonna be having the cost index 100% also. We can now set fuel freezing temperature -37 degrees, cruising center of gravity. So the legs now can be executed. It's gonna activate the route. So we have first waypoint 136 degrees heading 2 nautical miles from the runway, 1,900 feet, 324 knots. So we climb, make left turn, 1 nautical mile, 356 is the Zui, it's heading 052, 324 knots, 6,000 alpha. Climb to the Negria 071 heading 26 nautical miles from Zui, Mach 0.576, 25,300. Then we make a right turn, 230 heading 12 nautical miles, Mach 0.576, 25,300, 6 nautical miles. Amiki Then descent 9 nautical miles, Zurich 180 knots, 7000 alpha. From the cruise level, Zurich 701, Z8701, 180 knots, 6000 alpha, 6 nautical miles from Zurich. Then clear rain 290, 10 nautical miles, 185,000 alpha, CI 14, 6 nautical miles, 184,000 alpha. We make left turn here for alignment with the runway, 5 nautical miles, Rosenham 324, 4,000, runway 14, 8 nautical miles, 140, 1,430. So we use 15 degrees of flat center of gravity, automatic 23% over here, and the takeoff speeds V1, V rotate, and V2. Also we can use other modes. So we have initialize, route, departure, arrival, alternate, VNAV, progress, hold. We can use waypoint to hold, fix navigation radio. We can tune the ILS and the VOR and NADS here. So we're going back in the virtual cockpit. We need to set up now for setting up the engine start. So we're going over here in the overhead panel. We're gonna set up the APU on. The battery left and right IDG 120, 400, 120, 200 volts, 400 Hz frequency. Engine driving, contactors also. IDG, heading reference, primary flight control computers, flight control surfaces, battery, downwind power over here, FD door, passenger oxygen over here, window heat, the rammer turbine. We have the hydraulics left and right engine driving in the off position, both of them. Engine driving primary in demand. You see the fault displayed over here, so we use back on and then to the auto position like this. We have also wing and engine RDIs over here, so we can set on auto. We have also cabin pressurization over here. We can set the outflow valves auto. In the manual we use the outflow valves open and close to pressurize the cabin when climate set. So we'll use the auto position again. Also we have the bleeder, the pressurizer from the engines to supply the cabin pressurization with the engine RDIs over here, and the hydraulic fluid pressurization and oxygen in flight. So we have also over here the recorders, the cargo and APU fire over here, some other systems, electronic engine control for the engines over here, normal and alternate mode that control the fabrics and the auto start. So we can start the engines like this using the auto start function. We have the fuel jettison. We can dump some fuel and select the nozzle and how much fuel to remain. If we arm this to make an emergency landing, we need to lose some fuel. So we have the left and the right wing fuel tank. The crossfeed we can use to feed either engine with our pump or either tank, and balance also the fuel between the left and the right wing. So we can use also, this is the fuel panel. So this is all we need to know for the overhead right now. I'm gonna set up now the autopilot. You can see the display here, the plan also, map setting over here. So a better look over here. You can see the runway we're gonna use for takeoff and for landing. Also you can see the taxiway here, the runway, and now the terrain in front of us, the angle of takeoff over here. So you can see the terrain and the aircraft symbol takeoff over here. So we have the runway in front of us, and the taxiway also as displayed from outside, and the terrain you can see the GPS also displays. So we set a little bit further away, you will see further away information in the range. So I'm gonna show you now the instrument, the other things we need to set up. Over here the systems information. So the systems is in the overhead panel. So we have the hydraulics over here, the APU is running, oxygen and liquid cooling over here, as you can see. Also you can see the electrics left and right, 200 volts, 400 Hz frequency. The APU is running, the batteries, voltage and amperage over here, the drive, and so we have where the electric is used, hydraulics, where the hydraulic fluid goes with systems, use it over here. Also start off valves, primary in demand, 5100 psi's left and right and center, and the quantity of hydraulic fluid. Also electric C1 C2, the fuel left and right wing, center tank, how much fuel we have, 11,000, 11,000, 11,000, total 32,700. When high pressure fuel valves, left engine, right engine are open and feed both engines. Also the cross feed valve can feed either engine without a primary the tank, but it's off right now. Also the APU is fed from the left wing using the DC motor. You can see also the minimum fuel temperature minus 37 degrees, and the temperature right now of the fuel below which the fuel will freeze. So we have the recirculation from the farex automatically of the fuel, and the lubricant and the oil sides are recirculated to the engines to heat it up in flight. So we have the bleeder from the packs, and for the oxygen the doors are closed, the cabin can be pressurized, the temperature of the brakes and the pressure of the tires. Also flight controls over here. We can move the flight controls, see the deflection of the flight controls, climb and descend, the rudder pedals also. So we have full flight controls, deflection like this, flight stick or control column. So we have also over here FS display over here, status, maintenance over here, and circuit breakers. And the last thing, the checklist, normal menu, what to do before start, after takeoff, descent, approach and landing. Also navigation display again. So we turn off both engines right now and restart them like this. Both fuel control in the off position. We have the APU on, so you will see what happens now. We have fuel starvation from the systems, so we need also the light. So we see the engines are going off right now. So we have the engines off. We need to come here in the overhead panel and restart very quickly both engines in the auto start position. So auto start on. You can see we have bleeder pressurizer into both engines from the APU running as displayed. So we have above 20%. We have pressurizer right now inside the engines. We're still not having fuel, so we admit the fuel flow right now. Very quickly, both fuel control in the on position. So to start in the on position, you see what happens. 34%, 35, 45, 50. So we're almost ready to go for takeoff for the auto start. The systems keep rolling. So we're gonna be having at 61% both engines are running, so we can go for takeoff right now. We set all the flaps for takeoff like this. It breaks up. We need also the heading of the runway over here. The airspeed we can set later in the air, and also the vertical speed over here. You can set the vertical speed like this. You can see, or climb. So we're gonna be climbing. Set the vertical speed. I'm gonna set the altitude like this for flying, and also the airspeed later is okay right now. So we can we go for takeoff. We got the clearance from the air traffic control, parking brakes off, advance the thrust levers over here. So we use the tiller for alignment. So we have the runway clearance, runway 14. We need to go and align into position. There is no traffic right now to the runway, it's only us. So we align over here with the runway heading, as you can see, with the center line using the tiller. So we advance the thrust levers over here to full takeoff power, and press the yoke down until 80 knots. Use a little bit rather pedal for alignment. So we have 35, 80, 90, 100 knots. So we have 120, 130. We rotate over here, so pitch up slightly 9 degrees or less for the takeoff rotation, as you can see. So we take off. We have the positive rate of climb over here, not a gear up. So we depart, as you can see, positive rate of climb. So you can see all the air data we have here now concentrated in the screen. You can see the airspeed 190 knots, the stall speed here. We are 2000 feet above the ground, 2100, 200, 300, 400, but 3900 above the sea. We climb with 5900 feet per minute. The airspeed now is decreasing because the pitch altitude increases, so we decrease. We have the stall speed, we have the wind direction and speed, the flight plan, the terrain and the horizontal and the vertical. You can see we are like 3000 feet right now above the ground. The terrain, it keeps climbing the aircraft, so you can see the terrain. This green wave below you is the terrain. Also now we have the stall speed with the red and amber indication. Over here we need to avoid the stall, so we're gonna start turning. You can see also a little bit further away. So we keep climbing over here. You can see the terrain, also the engines indication, amber, green and red indication here. So we go in the outside view, and now we need to start the turn now. You can see with us depart here. We have the Zurich view, the Switzerland, and also the lakes here, the airport, the runways, and the Swiss Alps. So we need to start the turn. So we turn manually over here. So we make a turn, as you can see, full manual turn over here. You can align with the flight plan also. So we're gonna be having nicer views from outside the aircraft. Hope you like this view of the Switzerland over here. And we need like 12 more minutes for the video to end, for the record. So we have the Switzerland here, the Swiss Alps, the Boeing 787, and the lakes, this Germany, and the France. We're gonna be over fine here. So you can see the Boeing 787. We need also to come here for another turn in a couple of seconds. So maybe we're gonna use less flaps for increasing the airspeed. Perhaps it's gonna give us better result of the airspeed. There's a little bit more airspeed here. So you can see the stall speed red and yellow indication. We climbed 15,000 16,000 feet. The wind direction speed, the Zuri over here, the first waypoint we need to cross. So this is the view of the aircraft after takeoff over here, as you can see. The head-up display also, what it displays, same things pretty much. So we make the turn here to align with the flight plan. As you can see, the other side, what it displays over here. So we have 1 more minute to start the turn back to the airport. As you can see, keep flying. The air data over here also. The autopilot over here, we have the LNAV set. So now we're following the LNAV navigation. So we are flying here, as you can see again. The France, this side, my homeland, Germany, Bayern Munich in front of you, and the lakes, Switzerland and Swiss Alps. So we're gonna make the turn now, go back to the airport. So we start turning, as you can see, very fast turn. Use a little bit right rudder for the turn also. So we overflying here this area, the Bayern Munich, the France, the lakes. We have also the Boeing 787, as you can see. So we're going back over here, need to align with the right rudder right now for the turn, make more steep turn. We're gonna be leveling off in a couple of seconds and increase the airspeed like this. So we're gonna be aligned, flaps up over here, increase the airspeed, as you can see. We need to fly through now. So we have the outside view over here of the aircraft. Hope you like the vapors, frozen vapors. So we're gonna be having here the view, the night view, galactic. A beautiful galactic view over here. The Germany behind us, the Bayern Munich, and the France on this side. So we need to start the descent now. So we initiate the descent, idle thrust over here. and extend the speed brakes like this. Bit more airspeed like this. So you can see where we're flying right now. Keep descending. So we keep descending like this, and we need 5 more minutes for approach and landing over here. So hope you like the view inside the aircraft also. Make a little bit of turn like this. So we're gonna make an approach like this through these waypoints. You can see also the other side view, the autopilot set the engine thrust right now, our airspeed, and also the head-up display indication. We need to make the turn now, so we start. Keep descending the same time. And we have 4 more minutes left for this flight, as you can see. So we need now to enter the flight plan here, the waypoints. Align also with the heading over here. Decrease the altitude, enter the flight plan and route over here. Now the gear down. Also align with the flight plan over here. Flaps also. So this is how we need to align with the flight plan. Also you're gonna see we have a few more minutes, like a couple more minutes for the record. So we need to align now with the runway as we are descending. It's gonna be hard alignment, but we're gonna make it. There's no problem for us. Also increase the rate of descent and use more flaps over here. So you can see the runway now where is position. We're gonna use this runway for approach and landing, so we increase the rate of descent a little bit for approach. You can see also the Lszh localizer over here. We're gonna use for landing over here. So we use a little bit more thrust, more engine power. And we have 1 more minute for the record to go. We have also a little bit side wind gust. We need to align with all flight controls, having the wind gust, and also a little bit of maybe crosswind wind gust and a lot of side wind. So we need to increase also the rate of descent over here. So we are almost for the touchdown. We are aligned. The flare over here, so we're gonna be flaring the aircraft, as you can see. Beautiful flare and touchdown, very beautiful, very professional. Parking brake zone, thrust reverse, idle thrust and thrust reverse over here, full thrust reverse. So here we are slowing down the aircraft and align with the rudder pedals to the side wing. We have, so here we are, we made it very beautiful landing. You can see all landing gear is perfectly safe. There is no breakage of the landing gear and its parts. Also the thrust reverse over here, so we cancel the thrust reverse